Wow, full room, popular talk. Last talk before lunch as well. So delighted to have Hadi here from Particular Software, the creators of In-Service Bus. Before I hand you over, I'd like to just mention two things. That time allowing, we will have Q&A at the end of the session, but as we're rolling into lunch, I'm sure, hoping it's not asking too much of Hadi to field any questions after that as well. And also for all of our speakers, feedback is incredibly important. I would encourage everyone for all the sessions that you go to today, go to DDDPerth's site and add feedback for the sessions that you attend. So without further ado from me, here's Hadi talking about Microservices UI composition.
Thank you. Hope you can hear me all right. This talk is about microservices UI composition, some challenges and some of the solutions. Just a quick show of hands, who has done microservices before? Okay. So before we get into the actual talk, I'd like to thank our sponsors who made this happen. So far, the quality of the presentations has been through the roof, which is really great. Now, who has seen this page before? A lot of people. The interesting thing about this page is, if you've had online shopping experience before, is that the question I ask, that does this page ever exist? You've seen this before, so it does exist, but what I mean is that, is there a notion of a HTML page sitting somewhere on a disk, or maybe if you're a developer, is there a concept of an aggregate root, like a product table of some sort behind this page, serving this up? If you have a little bit more in-depth look into the construct of this page, you can see there are areas that are closely related to each other, and some things are not as much. We could identify that in a few key areas, but the interesting thing is that in order for that page to get rendered, we need bits and pieces of information coming together and represented to us as a web page, so we could have that shopping experience. Now, where that data is coming from is where we want to have a look at today. Now, having a look at that page, we could identify a few key areas. Obviously, first one is sales, which manages price and currency conversions and things like that. There is the inventory, which tells how many stock, how many items we have in the warehouse and their availability. The next one is shipping. If you have gone, try to shop in Amazon in the US, you might see there are rules that it tells you that you're not allowed to ship this stuff to Australia and something like that. Those belong to a shipping service. There is the marketing aspect. There is the product name, the images, and description and things like that. And last but not least, there's the ratings and reviews and customer comments. So if we say we're going to design this system as a microservice, those are kind of your system services, or microservices, for lack of a better term. But in order to answer where the data should be, how the data should be flown in order to have that page rendered, we need to understand what a microservice is. So microservices have a few characteristics. First and foremost, it's an architectural style. Just like back in the day, three-tier architecture was a thing, microservices is an architectural style. Think of it as that. But it has a few characteristics as well. First and foremost is that it needs to, the services needs to be autonomous. Now, autonomy means a few things. Autonomy means that a service on its own should be able to operate. So that means that there is no shared state or shared database between the services. Another meaning to autonomy is that Microservice is something logical. It's not something physical. It's not a physical component that you deploy on your server or on the cloud. And it's a logical phenomenon where it has everything that's between the front end all the way to the back end. It all belongs to that service. Now, what this means is that think of it as a vertical layer or vertical slice. Everything from that HTML page all the way to the database on the back end, as well as all the server-side components, they all fit in that vertical slice, which makes a service or a microservice. Another aspect to that is how the team is structured to create that microservice. We'll get to that in a bit. But it means that the teams need to be a cross-functioning team. We get to that in the next slide. The other characteristic is about microservices is that it needs to be around the business capability. So something like, I don't know, authentication, you might have code bases, something called authentication microservices or authentication service. That's not really a business capability unless you're into authentication business. So it is very important for the services to be around business capabilities. There needs to be some sort of an alignment coming from the business, and that shapes and forms the boundaries of your microservice. And the last but not least is kind of the unfortunate name of microservices that implies certain size. So we need to understand how big or small do they need to be a microservice, right? So how large and small should they be? Is that the answer is that the size is irrelevant. You've seen that before. That comes from the concept of pizza teams. You might have heard from Agile before. And that is coming from Martin Fowler on his website, saying that the size of a microservice is not so much important as the team that's writing that or owning that. As we said, the team needs to be cross-functioning. They need to be able to manage all the aspects of that vertical slice from the UI all the way to the back end. So it means that the team needs to be a certain size. It's recommended somewhere between 1 or 2 pizza-sized teams to manage a microservice. Now, the longer answer is that the size isn't really that important. If you have done services, any kind of services using Java, you know that it's kind of a verbose language. You need to write quite a few lines of code to get the service up and running. And something like Go or Rust, you don't need that many lines to get the service up. So the fact that you rely on the language, it makes the whole number of lines of code to make that microservice kind of irrelevant. Now, we're going to have a look at how we gather that data that we saw on the first page, how we compose that page for the client sitting behind the browser. And it usually comes into 2 forms, where usually it's like pulling the data, so the browser or a user goes and fetches information from the services, or it's usually the other way around for some of the services like notifications and push and things like that. So it's usually one or the other. Gonna focus a little bit more on pulling side of it. So we'll see a few patterns, if you will. I'll call this one a pull approach. So you usually have your browser application. And if you have designed your system, as we saw, you end up with a bunch of microservices, for lack of a better term. And the way it works is that you open a web page, requests need to go and fetch all the information. But because you have your backend services divided, there needs to be some sort of quite a few issues going all the way to the backend, fetching all the information, bringing them back up to the client, and managing that whole request and response, and rendering that information for a user on a web page. Now, this has a few issues. On the back end, you have done your homework, and you've done your system boundaries and service boundaries are kind of decoupled, so everything looks fine. But on the client, because of the fact that it's issuing multiple requests to the back end, it causes a few issues. And first and foremost is that majority of the websites are running on HTTP 1.1, and that has a limitation of 4 to 8 concurrent requests. And that 4 to 8 concurrent requests is everything. That's images and JavaScript and styles and everything. So this, by definition, is going to slow down your experience or your website. HTTP 2 might be a solution for that, but majority of websites are not running on HTTP 2. Another issue with this approach is that imagine if you're rendering a list or a table or a grid where the information are coming from all those backend services, and because all the bits and pieces are in different services, you end up in a situation where you have an N+1 issue because you have a list and everything is divided up in the backend. So it has that flaw as well. Now, in order to work around that shortcomings, some people come up with this approach. Say, in order to get around that number of concurrent requests limitation, let's put something intermediary in the middle, and that intermediary thing goes around and fetches the information, and because that's running in the server space, it's not bound to that limitation. So it goes around and gathers all the information, and another good thing about this is that the client doesn't need to juggle with that request response coming from different sources. It puts them in a normalized form in that centric repository, and then the client goes and issues a request and gets the data back and renders that. Now, the way this is usually implemented is using batch jobs. And you got a bunch of batch jobs running in that thing in the middle, and they go and fetch the information, put it in the central repository. That's usually a sort of a cache, and the client goes and reads the information there. Now, it solves that concurrency issue, the number of concurrent requests, but what it doesn't solve or mess up is that it takes away that autonomy that we talked about. Because as soon as the information it goes out of your service boundaries, it's stored somewhere else, you can't trust its accuracy or it being fresh. If anyone has done batch jobs, they know that they're prone to fail. So one day you go to work, the batch job has failed, the information is stale, the client's still reading it, so it's not really trustable. Other than that, there is the issue of cache and cache invalidation. So as we said, you put this information in a normalized form. Now, because the price is coming from one service and the product reviews are coming in another service, you need to be able to invalidate part of that object in the cache, which is not easy. Now, there is a similar approach to that, called the push approach, where you still have that thing in the middle, but we reverse the order of the flow, so we're not reliant on that batch jobs that are failing. So what do we say? We go with a message queue. So we put in a bunch of queues in our services, and those queues are pushing all the information into that centric cache. And ultimately, client is easy to write because it needs to interface with just one thing. Doesn't need to juggle all the requests and responses, and it works just like before. This doesn't solve, it solves the issue with the batch jobs, but what it doesn't solve is that autonomy. Again, the information is pushed from the boundary of the service into that centric repository, but as soon as it leaves that a boundary of that service, it can't really trust its accuracy or the freshness of the data. The fact that we're using message queues is not that much important, because as soon as you have a message going, let's say, to update the sales information or the price information, there might be other updates coming through the pipeline to update the price further, so you can't really trust the accuracy. And it still suffers from the data, the cache invalidation issues. Now, the fact that in a real-world scenario it looks something like this, it makes it more complex. And that is usually a cluster of Redis caches or something like that that you need to juggle. It makes the whole thing even more complex. So what we need as a solution is something that doesn't compromise the autonomy of our microservices on the back end, and still is an easy enough solution for the client to develop. And we call this a ViewModel Composition. So you might ask why ViewModel isn't this about the user interface? It is, but the most complex part of that UI is the data that needs to get to the UI, but we'll show how we need to deal with the UI as well. Just another thing to note is that this only addresses the issue on the read side of it. It's about how to query the data and display it. It doesn't involve mutating the state or changing the data on the database, so that's another problem altogether. So in order to have a solution, we need to exactly design our services on the back end, but and also we need to have something running in the middle to be that intermediary thing. We call that the composition gateway. And from client's perspective, it's all good because you need to interface with only one thing, and that thing running on the server space, then once a request comes in, issues a multiple concurrent request to the backend services and fetches all the information. As soon as all the information come back in, one by one, it puts it back into a kind of a view model, a dynamic object, for lack of a better word, and then returns that to the client, and the client renders that on the screen as it sees fit. The good thing about this is that composition gateway is not an active thing. It doesn't go around and ask for information and stores it somewhere. And that means that we solve the issue of autonomy. So the data is still within the database of each microservice, and they own how long it's going to remain in the cache and things like that. If you want to introduce something like some cross-cutting concern like caching, you can do that at the service level. So if you remember, we said that there needs to be alignment from the business to cater for the business capability, and it makes sense as we see the services remain autonomous, so they manage their own state. Sometimes it makes sense for a service to go with the document database. Sometimes it makes sense to go for a relational database. And again, that comes back to the business capability and alignment with the business. You can make that decision on a service basis. And you can add cross-cutting concerns like caching, where it makes sense at the service level, not one cache or one rule fit them all. And it kind of makes sense because for something like a price service or a sales service, the price might change more regularly, maybe on an hour basis, whereas comments and customer ratings not as much, so you could have different rules for each of those services on how much you're going to cache and store the data. Same goes with something like error handling. It might make sense for you to be able to do that because, again, going back to the business, you need to decide what the user experience is going to be. If your product review service is not available, that's not the end of the world. You could still have their business. Whereas if something like a sales service is not available, you need to show an error page maybe. And this solution means that there is no tight coupling, as we saw. But in order for services to be able to communicate with each other, you need to have some level of understanding, and that's using a unique identifier. So when you say, go around and fetch information about product ID 10, all the services need to understand what that product ID 10 means. Now, for the UI bit, once you solve the challenge of the data, the UI is kind of easy. There is already a standard for it. It's called Web Components. Anyone used Web Components before? Okay, so look it up. If you want to, it's a standard. It's going to be supported by all major browsers, not the JavaScript framework. So you don't need to be relying on a specific framework for that. If you want to see the adoption, you could go to caniuse.com and search for Web Components. It shows which major browsers, which versions currently support that. But essentially, it gives you a framework to build your application as widgets. And it's a standard, as I said. It's a standard, as I said. Gives you encapsulation. So your UI widgets are self-sufficient. You don't need to tight couple them to each other. There is still way to communicate with other widgets using events. And it is composable, so you can create your whole application using widgets or components. Gives you things like custom elements and shadow DOM and HTML imports and things like that. Now, there is a quick demo to show how this all works in practice, but before we get to that, I'd like to emphasize this. Has anyone seen this code before? Yeah. This is called Conway's Law. It essentially tells you that your organizational boundary and structure is going to shape the way you create the software. So he did the research in 1968 and gathered around 4 teams and asked them to cooperate with each other and work with each other to create a compiler. And they all went away and worked together and created a compiler that was a 4-stage compiler. Not necessarily because the 4-stage compiler makes sense, but because the way the teams were structured that made an impact on the outcome. So this is very important to note because, as I said, for you to have a proper microservice, you need to be able to structure your teams so that they're a cross-functioning team so that you can manage all that vertical slice within your team's boundary. So I'll show you a quick demo. It shows you some of the stuff that I talked about in practice. I'll put a link at the end of the presentation to the code repo, so you can go have a look and see how it all works. Oh, there it is. Can you see that? Yeah. Sorry for that. That's not what I need to do. So this sample project uses ASP.NET Core, and it shows some of the concepts that we talked about in practice, and free and open source. The name comes from the movie that was on the slides as well. What makes you different makes you stronger, so hopefully got something to take away from this. Can you see that? So quickly, this sample has 2 modules or 2 services or 2 microservices, however you want to call that. And One is called sales, which manages sales information and order and things like that, and the other is shipping. They're all self-sufficient, so a team will be taking care of that, and each one has components like the database, the ViewModel Composition we'll look into, and there is also the UI bits. And the API host is the actual thing, the ASP.NET Core websites or web services that ASP.NET Web API services that will be running. There is some sort of communication between them, and we'll see how that works. And the main website is hosted in this application, and that's just the standard website. There is the concept of the gateway that we saw from the slides. That's also just to simplify things, is hosted here. So let me just show you a demo of how this works, and then if there's time, we go over the code a little bit as well. So you see that there are two different backend components running, and this is for the main website. Each of these services are just, as I said, ASP.NET Core Web API. So there's no communication between them at this point. And there is a simplified web application. And I'll open the developer's tool so you can see what's going on under the hood. And as soon as I go to my orders page, it's going to issue just one request to fetch everything. If I go to the network tab, you can see I filter for XHR, which is the web request to fetch the information, and you can see there's only one request being issued. This goes to the backend, and that composition gateway, as I said, issues multiple requests to fetch everything. And on the front end, we see that the result is compromised of the shipping information as well as the order information, all in one response. Have a look at that response in a bit more detail. You can see that it has multiple entries because it's a grid, and each entry has information from different services on the back end. And this is the scenario of a table, as I said, and this is another example where you have an identifier that you need to talk about, and that gets sent to all those backend services, and they can provide information for the client to render. Now, quickly going through the code, first of all, the UI bits are kind of easy because they are managed by the team working on that service. So you can have a look at the constructs of those widgets. It's kind of simple, but as you can see, it is like a grid column that renders or goes out and takes out that information from that response sent from the backend service. So the UI is kind of not interesting, maybe. The interesting is the ViewModel Composition. So you want to have a look at that. It's got a concept of an appender. And if you remember, we said that when you issue a request, that the composition gateway fires up requests going to the backend services, and they can chime in if they're interested in giving providing any information for that request, and that's where the magic happens. The match is telling you if you want to chime in, and the append is the actual logic to go out and fetch information. This is kind of a simple scenario where you go to your local web API and say, get me all the orders with the passed-in ID, and then put that all in a dynamic object. And then the dynamic object gets returned to the client. Same goes for when you want to render the shipping information. Again, same concept as before. It's an appender, and you go around and send that to a different service this time, and pick up the information from the response and put it in a dynamic view model, and then return it to the UI to render. And the actual UI is also, as I said, developed by the same team. So because of it might put you off at first thinking that if it's a dynamic object, we don't know what's in there. But because of the fact that the same team will be writing the backend component and the front-end component, they know what to look for and what it looks like when they want to pick that information. The only tricky thing is that there is a scenario where you need to load the information after a certain thing is loaded. Like the example of loading a shipping information for either multiple orders. First, you need to have those orders loaded before you have those IDs so you can have a lookup in the database to fetch their status. And for that, there is a concept of publisher subscriber. So you listen to an event called orders loaded, and once that happens, you go kind of do the same thing, but it's essentially, it's like a promise, or if you've used that kind of terminology before, it's just waiting for an event to fire off, and then that goes and does something. But the rest is kind of the same. And the last but not least, how to plug it in is kind of easy. So this is a standard ASP.NET Core application. All you need to do is to plug in this using this method, this extension method. And that goes around and tells ASP.NET Core, I want to plug in into the GET request. When there is a GET request, there's a component that will fire that off to multiple backend services. And this is where you can fine-tune what's going to happen if a service is down or crash or is not providing response on time, and then you can make that decision based on the requirements coming from the business. The rest is all in IT ops, and that's kind of the infrastructural code. And the way that it's all put together for the client's perspective is that, let's say you have a view, and the view is using those components created by the UI developer in that team, and then it's just put together and packaged as a web application ultimately. And just going back to the demo, the only thing that makes this all magic work is that the composition gateway is listening on a specific route, and if I can get this to show up, and as soon as you hit a specific route, that's going to get activated and fires up requests to your backend services. So /compose is where that gateway API gateway is listening, and as soon as it gets the incoming request, it fires up the request to fetch information, and it goes to the backend services. And that's the extent of it. If you're interested, the code is available on GitHub, and you could pick it up and see what it looks like in more detail. Okay. Okay. So the code is available in that URL. If you're interested in this subject, a colleague of mine has a blog post about it. It's called The Secrets of Better UI Composition. It goes into detail about the concept and a few strategies. There's also the Advanced Distributed System Design by Udi Dahan that goes into the subject of services, SOA, microservices, and UI composition. And there is a workshop in NDC Sydney if you plan to attend. That's also going over the UI composition stuff. Thank you for being here today.